Good day, everybody. In this video, I'm going to show you how we can use data from monitoring and estimate the day and the time of rock mass collapse. So let's look at this classical example. So this one you can see in many textbooks. This is a monitoring of a large open mining. So there was some slope that was unstable for some time, and you see the monitoring started in 1975, and the rate of the movement wasn't very high. So what they did, they just did some monitoring over a year, and at this moment you see that the rate of movement increased, and this is what we called that was regressive, and that was a progressive part of the monitoring of the movement. And that one, it just kept increasing, and at some point it collapsed. There was a failure. So based on this study, and I think two or three more studies, they did some investigation of how to predict the day at which this rock mass is going to collapse. And I will show you a few formulas, and then we'll do example to better understand how it works. Just keep in mind that this is very empirical, so it kind of gives you some idea what to expect, but it's not going to work probably in all the cases. But at least it will give a good starting point so that you can start planning for like next steps, your next step for the future, right? So let's look at this part of the curve where the movement is actually accelerated. And this is the very detailed data that obtained. So that was the failure at this point. So you see that it was kind of a trade line. It was like basically a straight line. And what we need to know to estimate at what point it's going to fail, it's the initial velocity. So initial velocity, we're going to estimate somewhere here at this point when you see there is change in the curve, right? And this is what we call V0. So that's initial velocity. And then once we have lots of points here, we can get a point in the middle. So that will be a middle point velocity, and we're going to get the ratio between these two numbers, and that will give us the constant value of k. So from the previous studies, the estimation is that k should be around -7. So I'm not sure why it's negative, but well, anyway, we just use a positive number here because it's on power of 2, but it should be around 7. So then what we can do next is that we're going to estimate velocity at which the rock mass is going to collapse. So that's the value of velocity. Here we would need to know the initial velocity at which it started the progressive stage of the movement. And we know that value of k that we just estimated. So that's how it works. And then once we know that velocity at collapse, so we can just find it here on the left-hand side of the plot, and then see how many days it will take to reach that velocity. So now let's look at the example on the next slide. So that will be the example. In this case, we have rock slide movements, and we've done some monitoring, and we already know that the movement changed from a regressive stage at which we just don't really need to do anything to progressive stage. So this is the stage at which we're going to expect failure at some point. And we know that change happened, that change occurred, that onset velocity was 0.01 meters per day. So that will give us a number of initial velocity of 0.01 meters per day. So now we have the data from monitoring, so it goes this way. And based on the data, the estimation of k was it's equal around -7.25. So what we need to do is we need to figure out how many days until the collapse, right? So we're going to do this using the formula to estimate velocity at which is going to collapse. So it's k in the power of 2 times the initial velocity. So we can put numbers at -7.25 in the power of 2 times the initial velocity, it's 0.01 meters per day. That will give us value of approximately 0.53 meters per day. So when the rock slide reaches this velocity, 0.53 meters per day, so at that point it will result in the collapse in the large length rock slide, right? Because it's about rocks. So now let's estimate how many days it's going to take to reach that velocity. We're going to look at the velocity axis here, and we're going to find 53. So 1, 2, 3, 4, 5. 53 is a little bit here, 0.53. So we have a log scale here. So that's gonna go, well, it kind of needs to be a little bit more accurate than what I'm doing. So we're gonna look at the point here. So here we're gonna have 61. So based on this data from monitoring and our calculations, the answer to this question will be 61 days, and after approximately 61 days, they will be collapsed, right? So it will result in a rock slide. Well, that's how we use the data. Again, be mindful that it's very empirical correlations. Maybe not very accurate, but at least it will give you some idea what to expect in the field in real life. Thank you for watching this video. Bye.